Let's solve this thing. In order to solve this, I'm thinking let's color this thing blue and this thing green, and let's copy them down here. So in order to find the area of this blue thing, let's look at this half of the rectangle. Let's get rid of this white triangle piece. We know this blue stuff is going to be the area of this entire square minus this quarter circle. So it's base times height minus 1/4 pi r squared. This whole square is 4 by 4, and the radius is also 4. So we can plug in 4 for the base, the height, and the radius. 4 times 4 is 16, and 4 squared is 16. 16 times 1/4 is 4, and we're left with the area of this blue thing being 16 minus 4 pi. Let's look at this angle right here. Let's call it theta. Let us look at this right triangle right here. The tangent of theta is going to be equal to the opposite over adjacent. The opposite is this 4, and the adjacent is the 8. 4 over 8 simplifies to 1/2, and in order to solve for the theta, we can do the tangent inverse of both sides. So I'm going to need a calculator for this. Tangent inverse of 1/2 set to degrees is 26.57 degrees. So let's plug that in up here. Let's connect the radius from the center of the circle to here, and both of these are radii, so they're equal to 4. That makes this triangle right here an isosceles triangle, so these base angles need to be equal to each other. And in order to find this third angle, I do 180 minus this, which gives me 126.86 degrees. There's a formula for triangles. Area equals 1/2 BC sine A, where A is any angle of the triangle, and BC are the two sides that contain the angle. So we can plug in 4 for those two sides, and 126.86 for A. All of this in a calculator is approximately 6.4. So the area of this triangle right here is 6.4. Area of a circle is pi r squared, and if we look at just a sector of a circle, the area of a sector is the degrees of the central arc divided by 360 times pi r squared. Well, this D is 126.86 degrees. So we can plug that in for D, and the radius of this is the 4 from up here. All of this can go into a calculator, and we get approximately 17.71. So this shape is called a segment, and the segment is equal to the sector minus the triangle. If you want to see that, if we plug the triangle in here, you can see that the difference between the sector and the triangle gives us the same shape as the segment. For the sector, we can plug in 17.71, and for the triangle, we can plug in 6.4. After we subtract them, we get approximately 11.31. Now let's bring that up. Now this red figure is what we're trying to solve for, so we'll call that x. Let's plug this 16 minus 4 pi into a calculator, and we get approximately 3.433. If we add up these three figures, it's going to be half of this rectangle. This rectangle is 8 by 4, which is 32. When we divide that by 2, we get 16. And from here, we can do 16 minus this, and we get x is approximately 1.25 square units. And we can put a box around that. How exciting. For more fun math stuff, check out andymath.com.